Hi everyone, this lesson is a last minute Lucy quiz review for chapter 7 quiz that's coming up, going over some basic inverse functions for trigonometry. So let's get started. The first types of questions you might see are like this, where it asks you to determine the angles that make this expression true. So what they're asking you is where is. So when it says sine to the -1, we actually say arc sine. So that's saying where. Where means what's the angle. So what's the angle? They're looking for an angle where the inverse sine, where sine is -1/2. So recall that your restrictions for sine are from -pi/2 all the way to pi/2. So here's pi/2, here's -pi/2. And so with this information and with your restricted domains, sine can only be top or bottom here, first or fourth quadrant. So where is sine -1/2? Now there's a couple ways you can think of this. One way, first of all, you know that it's not positive, so then it cannot be in this quadrant. So it's going to be negative. So in this, it must be in this quadrant somewhere. So what you're looking for is sine in a cosine xy, this point right here where sine is, would be -1/2 because it goes cosine sine. Where this is would be √3/2. So you can think of it like this and say, well, where am I? Where sine is 1/2? Well, you must be at -pi/6. And so going down, that's what you would go. So you're like right here. That's you. You have an option to go up or you can go down. You're going up if it's positive, you would go down if it's negative. You're not ever going to go in this restricted area. You cannot go outside of your restricted area. So it's not going to be anywhere over here. The other option for completing this problem is you also could have looked at this triangle here and said, well, sine is opposite over hypotenuse, which means that my hypotenuse would be 2 and the opposite side would be -1. And if you're thinking of that, you're thinking, well, what angle would be opposite of 1? Well, that would be a 30-degree angle. So going down 30 degrees, I could say -30 degrees if it's asking me in degrees, or I would say -pi/6 if the question warrants a radian answer. But this is another option for you to do. For this problem here, cosecant, that is the reciprocal function of sine. So sine would be, of an angle, is always going to be opposite over hypotenuse. So therefore, cosecant would then be hypotenuse over opposite. And so this would be √2/1. Now, for this problem here, we're going to draw a graph, and I do expect you to draw a graph for every one of the problems, like a little axis. Cosecant, again, being a reciprocal function of sine, has the same restricted domain that sine does, from -pi/2 to pi/2. My hypotenuse, and by the way, this is positive, so it's not going to be down here, it's going to be in the first quadrant. So now, with the hypotenuse at square root of 2, and the opposite side 1, this looks like a 45, 45, 90. So that would be 1, 1, square root 2. That's a 45, 45, 90. So therefore, where we are is pi/4. So it's as if you're taking this, your pi, so like from here to here is pi. What it's doing is it's saying, well, this is half a pi, and then there's a fourth, so that's pi/4. So again, we're at pi/4. If it asks you for a degree, you would say 45 degrees, or you would say pi/4 if they're asking you in radians. For this problem here, tangent also has the same restricted domain that sine does. It would be, again, from -pi/2 here all the way up to pi/2. The way you would write that just is like this, -pi/2, including -pi/2, all the way to pi/2, and that's your restricted domain also for tangent. Because this is positive, we can eliminate this down fourth quadrant. So we know that we are in the first quadrant. So where is tangent? √3/3. Now, tangent of an angle is going to be the opposite over adjacent. Now, I don't necessarily, though, want to make this opposite and this adjacent, because what you're really looking for is what's the angle where tangent is root 3 over 3. So when you're thinking about that, I want you to think, where did this root 3 over 3 actually come from? And what I would hope that you would come to is that before this was simplified, it was actually 1 over the square root of 3. And so what they're really asking me is, where is tangent 1 over root 3? There's my opposite and there's my adjacent. Because, when you're trying to remove the root from the denominator, you're going to multiply by root 3 over root 3, and that's going to give you this right here. But when you're going backwards and you're trying to put it on the triangle, it's not going to look like that. It looks a little different. So we know that this would be 1 from here, because you're at the axis. This is you. Opposite is 1. Adjacent is root 3. And then therefore this is 2. You can use Pythagorean theorem to verify. But the angle opposite of the 1 would be a 30-degree angle. And so therefore that would make this a pi over 6. It would be in your best interest to remember that anything like root 3 over 3 is going to be a 30-degree reference. And then therefore, if I had asked you where is tangent like root 3 just by itself, right, that would have been a 60-degree or pi over 3. So if you can remember those, you're going to be in a better position, because you don't get to use notes on that. Okay, so this one is saying, where is cotangent negative 1 over 1? Cotangent being the reciprocal function for tangent. Tangent would be opposite over adjacent. So cotangent is adjacent over opposite. So we're going to draw our graph. Again, tangent and cotangent have the same restricted domain that sine does. And so therefore adjacent, this is negative. So we're going to eliminate the first quadrant. So we know we're in the fourth quadrant. Adjacent would be negative 1, and so that would be here. So from where you are, adjacent, you can touch that. This over here is opposite, so that would be 1. But remember, if you're going to the right, that's not actually negative 1. The 1 going down would be your negative sign. So just be careful. Even though the 1 is up on the top, on the numerator, you don't put the negative 1 here. You have to use your common sense a little bit. Going to the right is in the positive direction, but going down below is a negative value. So this is another 1, 1, square root of 2. Hypotenuse is always positive. So even though you have a negative, that's not going to be negative. Your hypotenuse, always positive. So where are you? You're here, right? You're here. We're not in the first quadrant. We're here in the fourth quadrant. Where are you? So this looks like going down is a negative 45 degrees, or you would say negative pi over 4. And I believe most people are going to say we would prefer to have radian values, but it's not wrong if it's negative 45, unless they tell you just put it in radians. This question is saying, where is cosine root 3 over 2? Now, cosine has a different restricted domain than all the other values that we just did. Cosine's restricted domain goes from 0 to pi, so 0 to pi here. And so therefore, we do have the positive values, we do have the negative values. Because this is positive, we can eliminate the negative side. So now we have the positive values, so we are here in the first quadrant. Cosine is adjacent over hypotenuse. So the adjacent side would be root 3, the hypotenuse is 2. That would leave this to be 1, which would then mean we're at a 30-degree reference, which is pi over 6. Now, pi over 6, you could again say or 30 degrees. A lot of you, I'm very proud to say, have memorized these points too, from the songs that we've been singing, I don't know how many times, but if you remember our song, and remember at this point here, if you can just remember the first quadrant, we go 1, 0, and then this point right here on the unit circle would be root 3 over 2, comma 1/2. And remember, it goes cosine, sine. The next point here, which was root 2 over 2, comma, root 2 over 2. And then the last point here, which was our 60-degree angle, would have been 1/2, comma, root 3 over 2. So one of our options is saying, well, where is cosine root 3 over 2? Remember, cosine is the first value here. So that's cosine, that's cosine, that's cosine, that's cosine. Also, this would be 0, 1, also cosine. But the 0 would be cosine. But when it's saying where is cosine root 3 over 2, it's here. And where are you? You're at pi over 6 or 30 degrees. So there's lots of other options of, how you're doing that, but that's just another way of doing that. This problem here is saying, where is secant 2 over 1? Secant, reciprocal function of cosine. Cosine being adjacent over hypotenuse, so therefore secant must be hypotenuse over adjacent. So drawing this, our restricted values, again, cosine and secant combined, they're the same values. This is positive 2, so we're going to eliminate our negative values, and we know that we are in the first quadrant. Secant, hypotenuse is 2. My adjacent side is 1. So this looks like a 30, 60, 90 triangle. Opposite the 1 is 30, so that would be 30. This would be 60, which would make this root 3. But all we need to know is where are we? And we're at a 60-degree reference. The other option of saying 60 degrees, 60 divides into 183. So you also could say pi over 3. Okay? For these problems here, we're asking for the exact value. And so you'll notice that an exact value is not an angle. Outside here, that's your sine, cosecant, tangent. Those are the values I want. If I had that arctangent on the outside and the sine on the inside, I would have been asking for an angle. But I'm asking for a value because that's the last thing here. So this is saying, where is tangent 4 over 3? Now, in this case, this sample tangent is actually 4 over 3 is not a special right triangle. So what I would do is you're going to draw the little grid, and you're going to say, well, tangent is, there's my restricted domain. Because this is positive, we can eliminate the negative. So we are in the first quadrant. And tangent being opposite over adjacent. You always do this inside first, and then you go out to the outside. So do the inside parentheses first. So we did the 4/3. 4/3 is opposite over adjacent. This looks like a 3, 4, 5 triangle, which is not a special right triangle. Those are 30, 60, 90s and 45, 45, 90s. But this is a triple, meaning we have some, we call them triples, Pythagorean triples, that are combinations of numbers that you see often, and they're always going to be a right triangle. And these are the ones, these are the 4 triples. 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. So you're going to see a lot of these these numbers. They represent right triangles that are my Pythagorean triples. Anyway, so we know that this is a 5 because of this being a triple. You also could use Pythagorean theorem. So the question was, where am I? Well, I'm right here. Here I am at tangent of opposite over adjacent. There I am. This is saying right there, what is sine of where I'm at? So what is sine? Sine is opposite over hypotenuse. So that my answer is going to be 4 over 5. So what you're doing is you're finding sine of wherever you are in the middle. Okay, let's try this one. Where is cosine? 12 over 13. Now remember, cosine has its restricted domain here and here. And so this is positive, so we can eliminate the negative. So we know that we are in the first quadrant, and cosine is adjacent over hypotenuse. And this does also looks like a 5, 12, 13 triangle. And so where is cosine 12 over 13? Well, it's right here. It's right here. So once you're here, this is asking you to find tangent of where you are. So what is tangent? Tangent's opposite over adjacent. So my answer would just be 5 over 12. Okay. This one, a little bit different because this one is a special right triangle. Where these two were not, this is. So cosine is there, its restricted values are from here to here. And therefore, the inverse function, where is cosine? Negative root 2. We can eliminate the positive area. We're going to go down over to here. We are here. Well, where are we? And again, just like that other problem where tangent was like 1 over root 3, became root 3 over 3, this one right here would have been 1 over root 2, or negative 1 over root 2, and then it became root 2 over 2. So if you don't know that cosine, where is cosine root 2 over 2, and most of you do know that, but if you don't know that it's a 45 degree reference angle anyways, that if you don't know that, then you can definitely say, well, this is adjacent over hypotenuse, because that's what cosine is. You do that inside part first. So the adjacent side would be negative 1, and my root would be 2, square root of 2. And because I know that when we have a root 2 and a 1, we know this is a 45, 90. I'll show you those triangles again in one of these, in one of the upcoming slides. So where are we? This is a 45 degree reference, or pi over, this from this space from here to here, that's pi over 4, this little reference. But that's not what I want. What I want is this angle from here to here, is 3/4. Okay, so what they're really asking me is what is sine of 3 pi over 4, or what is sine of where I am. So sine is opposite over hypotenuse, which is 1 over root 2, or that's going to simplify to root 2 over 2. Okay. All right. Let's see. For the next question, it says, where is cosecant, or arc cosecant? See this right here? This is what it's actually saying. Cosecant, arc cosecant. So root 5, let's say over 1. So this is saying, where is cosecant root 5 over 1? Now, cosecant is a reciprocal of sine. Sine, like cosecant, has restricted values in between first and fourth quadrant. This is positive, so we can eliminate the fourth quadrant, which is negative. So we are in the first quadrant, and cosecant is being the reciprocal of sine, upside down. It was, if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite, which would then be root 5 over 1. Now, most of the time, I'm going to automatically find that third side, just so I have it, because I could have asked, like, what's cosine of where I'm at, right? But because it's saying cosecant of where I'm at, what is cosecant? Well, cosecant, again, is hypotenuse over opposite. So I end up getting exactly what I started with. Now, it is important to note that it doesn't always work like that, where it's the same number inside, because it has to be within the restricted domain. Okay? So this is just going over some of the domain restrictions, and I'm going to also talk about the 3 triangles that I would expect that you would know. So the restricted domain for arc sine, which also is arc cosecant, is from negative pi over 4. So when you would ask what that restricted domain is, it's going to be from pi over 2 all the way to pi over 2 positive. Okay, including in the brackets, because they include these values right here. For cosine, the restricted domain also counts for secant. That's going to be from 0 to pi. So you would write it like this. So 0 to pi. Okay. For tangent, the restricted domain, again, is from here to here, which is negative pi over 2 to pi over 2. Also, you would write it negative pi over 2, comma, pi over 2. also, not only is it arc tangent, but it's also arc cotangent. Same. Now, I want to talk a little bit about why those values, why are they where they are? And so what's happening is if you were to look at, let's say, a sine wave, right? You're looking at the sine wave, looks like this, right? And a sine wave will continue and go on forever and ever. Sorry, Lucy. And like this, right? But realistically, if I want all the values that are both positive to represent both positive and negative values, well, then I would need this area right here, because this sign, this gives me that area, and these give me this value. So this right here being negative pi over 2, and this value being positive pi over 2, if I have my restricted domain right there, that accounts for both all the negative values and all the positive values, okay? Similarly, with cosine, cosine starts high, goes down, ends high, okay? And you would think that you would want to use the same restricted value, negative pi over 2 to pi over 2, but you can't do that, because if you did, then cosine would just be all positive values, positive values. You wouldn't be taking into account any negative values. So what's going to happen here, whoops. All right, so what's going to happen is that we need to take into account both. And so that would mean that if I went all the way here to pi, and I went from 0 to pi, realistically, I would have all of these values from here to here. That's what that's doing, is it's saying, here's my negative values, here's my positive values, I'm represented. For tangent, up one and right arm up. And then, of course, we've got our asymptotes at negative pi over 2, another asymptote at pi over 2. So what you're looking at with this is you're saying, well, here are my positive values, here are my negative values, everything's represented. Even if this kept going, right, I still am represented between there. Now, also, for these functions to be one-to-one, you have to actually stop your graph. It's got to go from here to here. Because remember, for a function to be one-to-one, it would pass my horizontal line test, which means it can only intersect once, where, as you can see, it would intersect more than one time if I didn't restrict my domain. So now that we've restricted our domains, our functions are one-to-one. And so therefore we can have an inverse. There you go. So these ones are a little bit unique because, as you can see tangent, tangent, sine, sine, etc. I chose these examples because I want you to see that sometimes you're going to get the same answer and sometimes you're always going to get the same answer. All right, so let's do this one. This one is saying here, where is sine? Always do the inside first. Where is sine? Well, that's not the right question, is it? That actually should not be there. Let me fix that, because you're not asking where the angle is, because you're kind of like, that is the angle. So, sorry. Let's just rewrite this, because this isn't right. So let's assume that that is not there, and I'm going to erase that. Okay, there we go. So this is not here. So what we're going to do is we're going to say, where is sine? Let's say, where is sine? I like negative root 2 over 2. Let's try that. And so where is sine in our restricted area from here to here? So where is sine negative root 2 over 2? And you would say, well, it's negative, so we're out here. And then you would say, well, I would be down here in this quadrant. It's negative root 2 over 2. I would be at here negative pi over 4, or negative 45 degrees. So then it's asking me, well, what is sine of negative pi over 4? That's what it's asking me. Well, sine of negative pi over 4 is negative root 2 over 2. So I did actually get the same value, didn't I? Not always going to happen, though. Not always going to happen. So the next question that I'm going to ask is here. What is sine of negative 2/3 pi? So negative 2/3 is going down this way, and negative 2/3 here. Now remember, 3 divides into 180 60 times. So we know that this is a 60-degree reference, which would then mean that this is negative root 3, this is 2, and this is negative 1. So where is sine? What is sine negative 2 pi over 3? Well, it's negative root 3 over 2. So you would go arc sine of negative root 3 over 2. So now this is what asking you. The second part of the question is saying, where is sine negative root 3 over 2? However, sine has a restricted area, which is here to here. So therefore, positives out, I must be down here, sine being opposite over hypotenuse, also 60-degree reference. Therefore, I'm at negative 60 degrees or at negative pi over 3, which is not the same value as that. For this problem here, this is saying what is tangent of 3/4 pi. So do this inside first. So 3/4 pi, 3/4. So 3/4 is over here, 45-degree reference, okay? We know that tangent, if it's 45 degrees, it's 1, 1, square root of 2, but also going to the left, that makes this negative. So what is tangent of 3 pi over 4? Well, it's going to be opposite over adjacent, so that's going to be negative 1. So now the second part of my question is actually saying, where is tangent negative 1? However, remember, tangent's restricted domain is from here to here. So this part's out because that's positive and our value is negative. So we know we're down here. And so therefore tangent is opposite over adjacent. So that would be negative 1 over 1, or 1 there. And then this would be root 2. And so this is saying, where is tangent negative 1? We're here. You went here, because remember, you could go up or you could go down. And because our angle is down here, therefore we can't go outside of that restricted domain. So I know a lot of students want to go, well, I'm at 1 and 3/4. No, you cannot do that. You have to go straight down. And so therefore you are at negative pi over 4. You're at negative pi over 4. Or you would say negative 45 degrees, but usually when one of these angles is already in radians, you keep it in radians. This part here is saying, where is tangent 2 over 3? Now remember, again, restricted domain, first and fourth quadrant. So where is tangent 2 over 3? Tangent positive. This is out. So I am in the first quadrant, opposite over adjacent. So 3. Let me make this a 3. And then, therefore, I actually don't need to find the hypotenuse, because right after it says, where are you? And I say, well, I'm right here. It's not a special right triangle, so I don't have an angle for this. But I do know that I'm right here. So now it's asking me what, this is what it's asking me, what is tangent where I am? Well, where I am is right here, and tangent is going to be 2 over 3. So this is always going to work like this. Always, okay? For these problems, this set of problems, they are asking me to write the trig function or expression below as an algebraic expression in terms of the variables given. So most books like to use U because when you go to calculus, you're going to see a lot of U substitution. I like to use different letters, but you can use whatever letter you want. Inside out. So we're saying, where is cosecant? U, or U over 1. So we're going to draw our little triangle like this. Cosecant being the reciprocal function of sine. Remember, sine has this restricted area domain of first and fourth. So where am I? Not here because it's positive. So we are in the first quadrant, and cosecant, reciprocal of sine, sine, opposite over hypotenuse. So cosecant is hypotenuse over opposite. So our hypotenuse is u, and our opposite is 1. We do actually need to find this bottom value here. So I'm going to erase that. And in order to find that value, we need to use Pythagorean theorem. So I'm going to call this side A, just for fun. And A is going to go away in a minute. But Pythagorean theorem says a squared plus 1 squared is equal to u squared. A squared is equal to u squared minus 1. 1 squared is just 1. And when I move this to the other side of the equal sign, it's the opposite value. And now to lose the squared value, we're going to square root both sides. And because, remember, this value going to the right, it is positive. So we're not going to say positive or negative. But this value right here for our A is now going to be the square root of u squared minus 1. Okay? So now you're here. So the question says, where is cosecant u? Here. This is where it's at, right here. So then the next question says, what if it doesn't have a negative 1? This thing, if it's not an inverse, it's saying what? And that you want a value, an exact value, right? As much as you can get with variables. So what is cosine of where I am? So what is cosine? Cosine is adjacent over hypotenuse. So adjacent is going to be, what is this? U squared, the square root of u squared minus 1 over my hypotenuse, which is u. Done. And so that's my answer. I will say some textbooks, not yours, will you'll see absolute values. So, I mean, it's not wrong to put those in because you know your hypotenuse is always going to be positive, but it's also okay to put that there, okay? This one is saying, where is sine h over w? Inside out. You always do the inside first. And so let's graph this again. Sine goes first and fourth. Now sine, this is positive. So again, I'm in the first quadrant. So I'm right here. And sine, opposite over hypotenuse. So opposite over hypotenuse. So this is saying h over w. All right. So to find this side again, we're going to say w squared minus h squared. So we're going to use that same thing that we did here, except different letters. So we have w squared minus h squared. So the next question, this one, is saying, what is tangent of where we are? We are here. So what is tangent? Tangent's opposite over adjacent. So that opposite is h, and the adjacent side is actually a root forgetting I was using w instead of u. And so we've got w squared minus h squared. And so what this is, now this would be my answer if I had to have a root on my denominator. However, I would probably take off maybe 1/4 of a point if you don't rationalize the denominator. And what that means is get rid of the radical sign. So remember, if I had had like 1 over root 2, I would multiply my expression by root 2 over root 2, because I'm not actually changing the question because I'm multiplying by 1. But I am going to simplify it, and by doing that, I'm going to get root 2 over 2. Whatever's inside is going to come out. So I'm going to do that again, but here I'm going to multiply this by the square root of w squared minus h squared all over the square root of w squared minus h squared. And so when I do that, I am going to get h times the square root of w squared minus h squared all over my denominator, which remember, when I multiply a root by itself, not the conjugate, the same value, you're going to get whatever's inside, and that's going to be w squared minus h squared. And that's my correct answer for full credit. So remember, try not to leave roots on the denominator if you can help it. For this problem, it's saying, where is cotangent z? Now, I know a lot of students today were asking me, hey, let's not use z. Let's use like a or c or something like that. So we're going to use, I don't know, how about, let's just go back to u. Let's go back to u. And so where is cotangent u? And so what that would be is cotangent, and that's a positive u. So tangent and cotangent are in first and fourth. So we can count out the fourth quadrant because u is positive. So tangent is opposite over adjacent, which would mean cotangent is adjacent over opposite. So if you are here, the adjacent side, we need a triangle. So our adjacent side is this side right here, and that's u. And the opposite side, which I don't see a value under here. So if there's no value under there, that's just going to be 1. So u over 1. And so therefore, my hypotenuse is going to be u squared plus 1 squared. A squared plus b squared, right? U squared plus 1 squared is equal to my hypotenuse squared. And to find my hypotenuse, I have to square root both sides. And that's where this u squared plus 1 squared came in. So now I need to find cosecant of where I am right now. And where I am right now is right here. And cosecant is a reciprocal of sine. Sine is hypotenuse over opposite. Or excuse me, sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So now I'm going to take my hypotenuse, which is this, u square root of u squared plus 1, and put that over the opposite side, which is 1. So I don't really need to do that, and I can just leave the answer as like this because anything divisible by 1 is still 1, or excuse me, is still that value. For me, the only thing I would change, and I know it's not required, but I do think that it warrants to know that the hypotenuse is always positive, never negative, okay? Where is tangent m over a? So I love this question. Again, tangent first and fourth. So tangent not down here because this is positive. So this is going to be right triangle here, m opposite over adjacent. And therefore, if I use my Pythagorean theorem, I'm going to get a squared plus m squared. Leave it like that. You may not take anything out. So many people think that the square root of a squared plus m squared is a plus m, which it's not. It's not equal to a squared plus m squared. It's definitely not. So for example, try 5 squared plus, 6 squared. No, that's a big number. Let's just go smaller. Let's think 3 squared, like 3. Okay, so 5 squared, what's that? 25, and plus 9. 25 plus 9 is 34, and so therefore that would be the square root of 34. Now, does the square root of 34 equal the square root of 5 squared plus the square root of 3 squared? What is that? 5 plus 3. 5 plus 3 is 8. Does 8 equal the square root of 34? No. So therefore, they're not the same. Okay. Okay. Let's go back to the problem. What was the problem? Here we go. We're in tangent. So up here is tangent. Opposite over adjacent. We did this. This is done. So now it's asking me what. Remember, there's no -1 on cosine, so there's no restricted domain. However, we are right here. This is our triangle. So from where we are and where you're standing, right there on the axis, 0, 0, what is cosine of where you are? Cosine is adjacent over hypotenuse. So you're going to say a over the square root of a squared plus m squared. And again, this right here is going to yield you almost a perfect score, but because you didn't rationalize your denominator, if there is a root on the denominator, you might lose a little points. So again, my final answer would be a root a squared plus m squared, and this would be all over a squared plus m squared without the root. And if you were me, you're like, Mrs. Smith, I'm going to be Mrs. Smith, right? You would put an absolute value here because the hypotenuse is always positive. The last type of questions that you're going to see are these ones right here. And these are equations, and your job is to find the exact value. And these are not difficult. You can do this. You're going to divide, you're going to solve for x. Your job is to find x, okay? You're isolate the x. So this is -4. You're going to divide by -4, okay? And what's going to end up happening right now is I have where is cosine x, which equals -pi/4. Now remember, when you move something across the equal sign, that's what actually that is an inverse. Like, for example, if I said x plus 7 equals 10, the fact that I'm going to subtract 7 from both sides is an inverse for addition. If I had 7x equals 10, the fact that I would divide by 7 from a multiplication problem is its inverse. So think about what would it mean if I were to find the inverse of an inverse. Well, that would just be cosine. So when I move this to the other side of the equation, this becomes x equals regular cosine of -pi/4. And so now it's asking me where, what is cosine of -pi/4? So I actually need to, I'm going to draw my little graph here. Cosine going drop down pi/4, here I am. Pi/4 is a 45-degree reference, root 2 over 2. And remember, in all students take calculus, cosine is positive here. So therefore, my answer is going to be positive root 2 over 2. I do like putting your answers in solution sets when you're solving an equation. Try to do that. For this problem, we are going to divide by -15 on both sides. So again, I'm trying to isolate the x. I'm going to divide this out on the outside. I'm going to get arcsine of x is equal to 5 pi divided by 15. Negatives are going to cancel. I'm going to end up with pi over 3. Moving the sign over to the other side, I'm going to get x equals sine of pi over 3. And so this is saying not where, because there's no inverse, right? Move the inverse out. What is sine of pi over 3? Well, let's see. What is it? You probably know this. 3 divides into 180 60 times. So we know it's a 60-degree reference. One of your options is to do this. Oh, that's 60. Opposite to 60 is root 3. That must be 2. That must be 1. Sine is root 3 over 2. Or you totally could have remembered your unit circle. Remember that here? Where you're going, okay, well, my 3 values that I should know going into the test, right, are root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2 root 3 over 2. And remember, it goes cosine and then sine. And so therefore, where is sine, or what is sine of pi over 3? Well, sine of pi over 3 is root 3 over 2, up there, 60 degrees. Divide by 8, divide by 8. I'm going to get where is cosine x is equal to -2 pi. And so now I have x equals cosine, not arc cosine, cosine of -2 pi. And this is saying, what is cosine of -2 pi? Well, -2 pi is going to give me the same value as positive 2 pi because I'm going all the way around the circle and ending in the same place. But when you're drawing your triangle or showing your work, you definitely want to show this kind of thing because that's showing me that you know that you went down and came back around. Anyway, so here's -2 pi. Where are you? You are at 1, 0. What is what? This is saying what? What is cosine at -2 pi? Well, it's 1. Remember, it goes cosine, sine. Cosine's your x value. So where are we? We're at 1. So x equals 1. Boom. Okay, so, hey, good luck on your quiz. I'm so glad you were able to watch the review video. I hope that helped you. And I'll see you next time. All right.